This video is going to go over how we use proportions in our modeling geologic time and how we're going to try and figure out where on our timeline we place various events in geologic history. We're going to be using a proportion equation just like you may have done in math class. On the screen here is our equation from the slides. Notice that we have written out here the entire 4.6 billion years. So when you write that out, there's our amount of time, and that's the number of years it takes to cover all that life has been on the planet. So from the current day all the way back to the first life on the planet is about 4.6 billion years. So we're going to use that as part of our scale, and as we place things on the timeline, we'll be using a proportion to help us do that. So before you start any further on this process, you need to think about what model you want to use. Maybe you're going to use a linear timeline. You need to know how long that linear timeline is. Maybe you want to use a clock, and you're going to use 12 hours time to show how much of that clock would be used for the various time periods. Maybe you're using a map, and you got to think about how many miles of the map you're going to use for your overall model. This is the point where you're going to need that. For example here, I'm going to use 1 calendar year. And 1 year contains 365 days. So we're going to use the time period between January 1st to December 31st, so 1 entire year, to show a scale model of geologic time. Alright, so in order to do this, we're going to use our equation, right? It's 4.6 billion years divided by your scale, right? In this case, I'm using 365 days as my example. And what you're going to end up with at the end here is years in your units, right? So how many years for your units? In our case, we're going to be getting years per day. So how in one day, one 24-hour period, when we get this calculation, tell us how many years are contained in that one calendar day. So let's find out our scale. So we got 4 billion. Got to make sure you get all the zeros in there. And that's going to be in years. And I'm going to divide that by my scale. And in my scale, I had 365 days. So I'm going to divide it by 365 days. And that's going to be equal to just 1 day on my calendar, right? So what we're going to end up with is 1 day, and we need to know how many years there are in that 1 day. So what we're going to do is we're going to go through and we are going to divide that. So I pull up the calculator here. So we're going to type in 4 billion 0.6. So we can make sure we get the right number of zeros there, right? And when we look at that, we can see that there's hundreds, thousands, millions, billions, right? It's also 4,600 million. So we're going to divide that value by my 365, just like I see in my equation here. We hit the equal sign, and there we have it. Right? So the amount that we're looking at here is 12.6 million years per day. We can see we can ignore all the significant decimals because we're talking about big numbers anyways. So 12.6 million. We should kind of start looking at this. So I'm going to pull up a calendar here so we can sort of see what's happening here. Here's December 2020. So if you look at December 1st, 2020, that contains just that 1 day on our calendar on a scale model contains 12.6 million years, right? That's how much time is there. So if you add up all the days in the calendar, 365 days, it adds up to 4.6 billion years in total. That's why we have a scale model. So let's explore this even further. All right, so we want to take a look at an example. So we need to know about a time in the some event. So humans appeared in the timeline about 200,000 years ago, right? So now we need to apply our method here, right? We know that there's going to be 12.6 million years per day. Right, on our calendar. So we need to know how many days does it contain the human, when the humans came up on the planet. So 200,000 years ago, right? So you're going to take your rate, 2.6 million years, and you're going to divide it by our number here, and we're going to get a decimal. pull up the calculator here, type in our 200,000. We're going to divide it by 12,600,000. Make sure I get all the zeros in there. And what I get is a decimal. Now we're going to round this to the nearest significant number. So we're going to put 0.016. Why not? 0.016. And our units would actually be, because we're looking at this, right? The units that we would have is 0.016, and that would be a total of days, right? Because that's what we figured out. We figured out our proportion here was 365 days. Well, what's that? It's less than a whole day. So I'm on December 31st here on the calendar. And I need to think about, wow, that's really, really close to the end of the day, because it's not even like half a day. It's not even a quarter of the day. 0.016. So we can further look at this if we really wanted to, and which we'll do. Why not? So to take this even further, then you're taking it down to how many hours, right? So we know that there's 24 hours in a day. So we're going to multiply this by 24 hours per day. Pull up our calculator again. So it was 0.016 multiplied by 24, and I get 0.384. So let's just use 0.38. 0.38. And my units on that would be hours. So we're not even at a full hour, right? We're not in a whole day. We're not even in a half a day. We're not even in a full hour. Or rather, it's 0.38 of an hour, right? So we're looking at a decimal of an hour. So if we think about it, a half an hour is 0.5. This is not even 30 minutes. It's less than 30 minutes. So how do we figure out minutes? Well, we know that there's 60 minutes in an hour. So I can go and use that. So let's do that. Let's multiply it by 60 minutes in an hour. And let's see what we get. We'll pull up our calculator. And so we're going to multiply that by 60 minutes. 23 minutes. 23 minutes. So humans on a scale, when we're looking at months, that's how far back. It's a really small amount. And if we're thinking about time, we can actually pull up a clock and look at that. Here we got a clock. All right. If we're looking at the time, right? Humans on our scale from January 1st until December 31st on our scale model, the time that humans are on our scale model, or the time that is represented here on the clock from 11:37 until midnight. That amount of time. In terms of days, it's 0.016 days, right? In terms of hours, it's 0.38 hours. In terms of minutes, only 23 minutes. We just scaled it down. So when you're doing yours, you are going to have to go through and think about how are you going to scale down your time. If it's going to be a number line, going from meters, centimeters, millimeters. If it's on a map, miles. How you scale down the miles. You think about how you're going to fit those big milestones. So remember, big picture here, folks. You're building your own scale. You got to think about what you want to use. Our equation is right here. Whatever it is that you're going to use as a scale, you're dividing that scale by the number 4.6 billion years. We're trying to figure out how big time is. And this is going to give us a visual, something that we can look at to help us think about that. All right, if you have any questions, be sure to email me, text me. We'll help you out.